Hey everybody, I wanted to make sure we all understood that example we kind of rushed through in class, which was example number 6 from your notes. F of x equals x squared times the square root of the quantity 1 minus x squared. Okay, so this one was multiple differentiation rules or multiple derivative shortcut rules, like we saw the product rule and we had the chain rule inside there. And I wanted to focus on factoring out these powers. So just going to rework this one to make sure we all understand it. So as you remember, we started off by simplifying this with algebraically, or properties of exponents. We brought this radical up and made it to the quantity of the power of 1/2. So x squared times the quantity of 1 minus x squared, all raised to the power of 1/2. Okay. So we see we have a product rule here, this times that, two differentiable functions of x, and then inside here we also have a chain rule. So I'm going to start with the product that's kind of outside of the chain rule. Start with the product and then we'll hit the chain rule inside with that derivative. So I'm going to start the derivative process now. So I'm going to use the f prime of x notation is equal to, so the product rule, the derivative of the first times the second plus the derivative of the second times the regular first. Alright, so the derivative of the first is 2x. It's the derivative of this piece times the regular other piece, 1 minus x squared quantity to the 1/2, plus the regular first piece times the derivative of this chunk. Now this brings up the chain rule. So as I suggested, I'm going to kind of use notation to say, okay, we still have to do the derivative of this piece, but I don't want to do it all in one step. So I'm going to use this notation to remind me that I still have calculus to do. So this is the derivative notation says differentiation has been done, but we still need to finish this part of it. Okay, so let's go and do that. F prime of x is equal to, I'm just going to rewrite this first part, plus x squared, no change there. I'm going to keep the brackets just so we know what happened from here to there. So the derivative of this, chain rule, the outer function is stuff to the 1/2 power, the inner function is 1 minus x squared. That's your stuff. So the chain rule says take the derivative of the outer, so the derivative of stuff to the 1/2 power would be drop the exponent in front, decrease it by 1. So drop that exponent in front, decrease the power by 1. So negative 1/2. Okay, so the derivative of the outer at the inner, or leave the stuff in there, times now the derivative of the stuff. So I look at the inner stuff and its derivative, 1 is a constant, negative x squared's derivative is negative 2x. Close off the bracket, and that bracket replaced the previous bracket above it. So it's kind of an indicator of what you were doing. Now, the calculus is all done. This says f prime of x notation. We have no derivative notation inside here, so the calculus is done at this part. Now it's just simplifying algebraically, so we've got a bit more work to do. So this first term I can't really combine. I can't distribute 2x into this quantity because of that power of 1/2, so nothing's happening there yet. This second part. Alright, I see I have 2 multiplied by 1/2. This 2 and this 1/2 are going to multiply to 1, so they cancel each other out. This negative symbol actually multiplies through with to this entire term, so I wish I wouldn't have written that plus symbol. I'm going to go back and erase that. I wrote in pen, so I can't erase it, but I'll scribble it out. This negative comes out in front. I've got an x here and an x squared there, so that's x cubed. So I've taken care of that part and that part. I've taken care of the negative, and that leaves me just this quantity. 1 minus x squared to the power of negative 1/2. Now, what we see is we have this quantity happening twice. or in both terms to different powers. So what that means is we can factor that out of both these terms. There's a big term, there's a term here minus a term there. This quantity is common in both of them. So this is the technique called factoring out least powers. And I'm going to factor that term out how many times, or to what exponent? It kind of makes more sense now. The lowest exponent I have is -1/2. So that's my least powers term, least powers that I'm going to factor out. When I factor that out of each of these terms, what happens? Well, this 2x term still needs that 2x. Now this power has to be such that when we multiply this by that, we get this back out. So the base is going to stay the same. And now I'm just thinking about exponents. When I multiply this by that to get that, I'm just looking at adding the exponents. -1/2 plus what gives me 1/2? Well, that's the exponent of 1. I could write a 1 there, but I'm not going to. I just leave it. The convention is just leave that. Okay? So just double check that. This quantity times that gives us that back. Okay? Minus, what do I factor out? Well, this one I factor all of it out. The -1/2 power agrees with what's already out there, so I factored out all of that. All right, so that's factoring out these powers. Now you're thinking, well, or you may be thinking, couldn't I have taken an x out of both of those as well? You could have. I just wanted to see this and factor out these powers. I could have factored out an x as well, but I can catch that in a later step. So by factoring out this least powers, now I can take this quantity and send it down to the bottom. So this numerator is going to stay up top, but I'm sending that thing down to the bottom and making the exponent positive. Okay, now I also see that up here I could distribute this in, because now I have an exponent of 1, so the parentheses is just making this multiplication the distributive property. And normally I wouldn't suggest doing that, not necessarily, but I can see that if I do distribute this 2x and that x squared, it's going to give me an x cubed term that I'm going to be able to combine with this x cubed term. So I am going to distribute 2x in. 2x times 1 gives me 2x. 2x times -x squared gives me -2x squared, and then minus x, this is -x cubed and minus x cubed. So 2x times x squared is -2x cubed. Okay, and then again, I'm going to work this part horizontally down here because I'm kind of running out of room. Now I have like terms. I've got that 2x on top. I've got these like terms, which give me -3x cubed all over that denominator. And again, if you're saying, well, can I factor out an x from that numerator? Sure, we can do that. Again, you're going to kind of use the convention in the back of your book and say, well, if you stopped here, does your answer match what the back of the book has? So you might have to do some extra algebra. Usually we're looking for, can I cancel stuff out by using factoring methods? So there you go. That's that example using the product rule, the chain rule, and factoring out least powers. Enjoy in moderation.